So here is where everything we learned sort of coalesces and comes together. Hypothesis testing. So hypothesis testing is a really big part of statistics. Hypothesis testing is really just where we try to make decisions based on probabilities of events. Where we went through this part. So just an example to kind of give us a jumping off point. Air pollution is a serious problem in many cities. One form of air pollution is particulate matter, which refers to particles that can be trapped in the lungs. One study published in the Journal of the Air and Waste Management Association reported that the mean amount of particulate matter produced by cars and light trucks was 35 milligrams per mile of travel. So a new engine is designed to reduce this level. So remember, this is your average amount. This is usually what we see on average across all cars. A new engine is designed to reduce this level. There are two possibilities. Either the new design will reduce the level or it will not. We're really looking at, like I said, it's complements here. Either it's going to do what they claim it does or it does not. You have two choices here. So like I said, two choices, it works or it doesn't. These are called your hypotheses. So one hypothesis, which we call the null hypothesis, says that the new design will not reduce the level. So a null hypothesis is assuming everything stays the same. Oops. It's an important word and letter and stay there. We designed this new engine, nothing changed, everything stayed the same. Same amount of particulate matter that we're going to be getting as any other engine. So our mean would stay the same at 35. Another hypothesis called the alternative hypothesis states that the new design will reduce the level or our mean is going to be less than 35. So your alternative hypothesis is that things are not the same. Or really what's looking at is there was an actual change that we're seeing there. So in essence, this is all really what hypothesis testing is that we're going to have a claim and our claim will either be things change or things don't change. It's one or the other. And it's our job to use some probability here to try to decide which hypothesis is it that we are going to favor. So this is not looking at something like we have all evidence, we prove something has worked. We're really looking at do we have evidence to support particular claims. So in the null hypothesis, what we use this null zero here, or sorry, H null, not null zero. So a lot of times we call it H null because of that subscript. This states the parameter is equal to a specific value. For example, that null hat is going to be mean is equal to 35. So equality is the important part of a null hypothesis. Null hypotheses are always going to be the ones that are equal to. Alternative hypothesis. So you'll see different notations for it. So this is an H subscript 1. You might also see, if you look this up, you might see an H with a subscript A for alternative hypothesis. This hypothesis states that the parameter differs from the value specified in the null hypothesis. So basically not equal. In one way or another, it's not equal. So there are three types of alternative hypothesis. And also just to state here, there's other ways to state our null hypothesis. We're just sticking with one of the ways that we state a null hypothesis. But null hypotheses always have equality. And alternative it will have no equality whatsoever. So we're looking at either we have a greater than, a less than, I thought it was backwards, a less than, a greater than, or simply not equal to, where a null hypothesis is always going to be equal to for our cases. So we have a couple things that can happen. We can have a left tail hypothesis test. So left tail hypothesis test is essentially the idea that we're looking for something. Null hypothesis is saying my mean is 35, but we are saying that we are looking for things less than 35. And that's when we do a left tail test. So your right tail test, we're looking at distribution. It's centered around 35 because we said that's the mean that we usually see. This is the example. We're looking for a parameter is greater than the value of the null hypothesis. So we're looking at the greater than, so we're in the right tail. And then the two tail, this is simply that things are just not equal. So two tail hypothesis test states that the parameter is not equal to the value of the null hypothesis, meaning that there's 35, I could be here, I could be higher than, or I can be less than. So this is saying could be essentially that our mean is less than 35, or our mean is greater than 35, but we're going to coalesce this all into simply just saying, well, our mean is anything but 35, because it can be one side or the other. So that's when you get your two tail test. So left tail test, we're saying that the parameter is actually less than what is stated in the null hypothesis. So what we're looking for is less than 35. Right tail, our parameter is greater than what is stated in the null hypothesis. So our mu is greater than 35 in this case. And our two tail is simply that the parameter is not equal to the value of the null hypothesis. So it can be in the left tail or the right tail. So we just say it's not equal to 35. That's how you got a left tail, right tail, and a two tail test. All right, so doing a little practice here, we want to state the appropriate null and alternative hypothesis. So remember, null is always going to be the equality, alternative is anything but equal to. We're going to draw a little picture of what we're looking for here. So boxes of a certain cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. So we're looking at a distribution like this, and they claim that it should be 20 ounces, meaning that's where I'm averaging, but the inspector thinks the weight is less. So this is what the inspector thinks is happening, is that we are going to be less than, we're going to be in that left tail. So this is going to be a left tail test. And we have the two hypotheses, or hypotheses. So null, that's my H with a 0. This is the one where nothing has changed. So everything stayed the same. So boxes of cereal say they have 20 ounces. Null hypothesis says, well, if I grab some boxes of cereal and I test them, I should find a mean of 20 ounces in all my boxes of cereal. The alternative hypothesis is that something has changed. It's not what has been stated. And here, the inspector thinks the mean weight is going to be less than 20. So if I collect several boxes of cereal and I find their mean, it should be less than 20. So that's why it is your left tail test. You're looking for that less than aspect. There go one more extra. There we go. That one a little too far. I didn't. So we're going to do this again, but now we have last year, the mean monthly rent for an apartment in a certain city was $800. I'd like to know where the city is. So that's what used to happen. That was the mean. A real estate agent believes the mean of rent is actually higher now. So we expect it to be up here somewhere. So this is going to be your right tail test. So your null hypothesis, the hypothesis where nothing has changed. So last year, mean rent was $800. We expect that this year, mean rent is still $800. Nothing changed. Alternative hypothesis, that's where something has changed. And that's saying that we're supporting that realtor saying that they believe that rent is now greater than 800. So notice, like I said, I'm only using strictly less than, strictly greater than. No equality is going to be seen here. And null hypothesis always set equal to, so it's always equal to what has always been stated. All right, and then our last test. Scores on a standardized test have a mean of 70. Sorry about that. It's my dog's outside. Modifications are made to the test, and an educator believes that the mean may have changed. So here, we didn't say the mean is smaller, or it's not less than or greater than, it's just may have changed. So we didn't state less than, didn't state greater than. Meaning that it could be here or it could be here. I should say not just. It's not just less than, it's not just greater than. It could be either. So once again, we look for our null hypothesis and our alternative hypothesis. Our null hypothesis is going to be standardized test scores have always had a mean of 70. And after the modifications, that mean is going to stay 70. The alternative, though, this is where things change. The alternative is we made modifications to this test, and now the average isn't 70. We don't know what it is, but it's definitely not 70. Like I said, so it could be smaller, it could be greater than. Here it goes, trying to get some move forward. So go through this one more time. We're going to state the appropriate null and alternative hypothesis for each one of these cases. So we have our first case is last year. Draw a picture on the other side too. So we have that last year, the mean amount spent on customers, spent by customers at a certain restaurant was $35. So automatically we know null hypothesis is where nothing changes. It's going to say 35. So the mean amount at this restaurant was $35. Restaurant owner believes that the mean may be higher this year. So greater than 35. So we have here, like I said, your alternative hypothesis is always the one where we expect a change. Null hypothesis saying, well, last year the mean amount was $35. I think this year the mean amount is $35. Alternative hypothesis is, even though the mean was 35 last year, I think it's greater this year. So it's still looking at what happened this year, but it's going, one is saying nothing changed from last year, and one saying it's changed from last year. So once again, if we were to show this in a distribution, this is 35, that was the mean last year. We're thinking that the mean could be greater this year. So we're looking at a right tail. So when we actually do a test, we know this is a right tail test. In recent years, the mean weight of newborn babies in a certain country is 66 pounds. A doctor wants to know whether the mean weight of newborn girls differ from this. So once again, we know in recent years the mean weight of newborn boys has always been 6.6. So we want to see if girls are different. So we're comparing two populations to each other. So we know boys are 6.6. If girls are different, they won't be 6.6. So once again, if girls are like boys, is what we're looking at here. If girls are like boys, they should have the same mean weight. If girls are different than boys, they should have just a different mean weight. So our boys are here at 6.6. We think girls could be here or girls could be here. So this is where we have our two-tail test. A certain model of car can be ordered with either a large or a small engine. The mean number of miles per gallon for cars with a small engine is 25.5 miles per gallon. An automotive engineer thinks that I took my T there by accident, that the mean of cars with large engines will be less than this. Makes sense. So once again, we're just comparing two populations. So what we want to know is, we think that automotive engineers think that we can find that cars with larger engines are going to have a smaller mean miles per gallon, meaning alternative hypothesis is where we see change. Well, I expect that the mean, when I look at large cars, to be 25.5. However, the other thing that could happen, this is our null hypothesis where nothing changed, maybe cars with large engines are going to have the exact same miles per gallon. We can't necessarily say that's not going to happen. It could possibly. It's probably not going to. But it's not for us to decide what we think could happen. It's for us to figure out what is happening. So in this case, we think that it's going to be smaller than 25.5. So we're looking at a left tail test. So the purpose of a hypothesis test is to figure out how plausible the null hypothesis is. So we're always we're going at this assuming the null hypothesis is true. So it's kind of what we're assuming. So we want to see is how plausible is that? Is it really true? So the idea behind a hypothesis test is similar to a criminal trial. At the beginning of the trial, the defendant is assumed innocent. So we assume the null hypothesis is stating the truth. So we need to gather evidence, and we need to have really strong evidence to show that no, the null hypothesis is not telling the truth. It is, in fact, false. It is incorrect. So in a hypothesis test, the null hypothesis is like the defendant in the criminal trial. So we're kind of, like I said, we're kind of trying to, we assume it is innocent, and we're trying to gather evidence that it is not. And if I cannot get evidence that it's not true, it has to be true. So if the evidence is not strong enough, to say that null hat is false, then we basically assume that null hat is actually true. So it's just like a court case. Ideally, what we are supposed to do is, you are assumed innocent to proven guilty. Same idea. We assume the null hypothesis is true unless proven false. So to start a null hypothesis, we assume, or start a hypothesis test, we assume that the null hypothesis is actually true. We look for evidence, which comes from data that we've collected. And if the data strongly indicates that the null hypothesis is false, we abandon the assumption that it is actually true, and instead we side with the null hypothesis. So this is referred to as rejecting the null hypothesis. So we do two things. We either fail to reject or we reject. So we can either fail to reject the null hypothesis, which means we didn't have any evidence. So we had no strong evidence that was wrong. Or an alternative that we can do is that we just reject the null hypothesis. That means we have strong evidence that it is false. So like I said, so we always assume the null hypothesis is true. We look at our evidence and consider it. And then from there, we decide, do we fail to reject the null hypothesis? we retain it, say that, well, this is probably true, nothing has changed? Or do we reject the null hypothesis? We have strong evidence against it, and we would say there has been a change. So this is really the essence of what a null hypothesis is. It's just, you're just looking, like I said, you're basically putting the null hypothesis on trial, and you're deciding if it is innocent or if it is not innocent.